here we have one more thing, that is local depth type declaration. That is nothing but when user defined data type will only be used within a specific part of a design. The type definition can be made within a module or interface representing that portion of the design. This is called local type def. You are using within a specific part of the design or within a module or interface. Look at here. Here we are having module of ALU, and we are declaring type def bit 0 to 3 nibble variable name. So in nibble we are declaring opcode A, opcode B, like that we are declaring. So those also will have the same width. Now what's happening here, we are declaring 32-bit vector. Now what will happen? Are you able to get this one? Actually the nibble is a bit data type having the range of 4 bits, width of 4 bit. Now we are declaring variable name is data, that's having a width of byte 8 bits, and already we this nibble will create 4-bit width, so it will create a 2-dimensional variable, right? So that is nothing but 32-bit vector made from, yeah, that's also possible. We can say in that way also total number of bits. So totally we are having 4 into 8, 32. It's made up of 8 nibble types, right? Okay. Next, so far we have seen local type def declarations. Next we are going to see about external type def declarations. When user defined data type is to be used in many different models, the type def declarations can be declared externally in compilation unit script. Okay, getting. So far we have seen, if you want to use inside a particular interface or module, in that case you can declare it as a local type def. But if you want to use the same thing in so many modules, then you can declare it as a declare it in outside, and that too in compilation unit script. For example, now look at here. Here we have declared that user defined data type in the compilation unit scope, right? If def tick in the end if. Okay, now what will happen in this module? We are going to use that one. Where we have used d type. Here using d type. Here we declare it as a count. Inside we are using those things, count. So this is an example for external type def declarations.
Means we have to assert, we have to make toState equal to 0 over there to use this logic data type.
I'm not getting.
To use this that logic d type underscore t.
D type underscore t. Okay.
We have to make toState equal to 0 over there. To underscore state. That is
Where you are?
That is the variable. Na? We have
This one. This one.
we have to make it as
Switch. Yeah.
only we have this will execute. Right now.
No.
If
You are if you're not enabling this switch, what will happen? Automatically it will go to here. So it will declare it as a logic instead of bit. That is
so
it.
we have to make it 1 then.
If you want to declare it as a bit, then you declare this as 1. Hello. Okay. Getting? If you are
if we want d type underscore t to be used na,
right.
then you should assert that two state.
No, it's not like that. If you're not asserting this two state, it will go to this else part. In that case also d type t is there, but only thing is here data type is different.
Okay,
That's
okay.
it.
Okay, okay,
Okay.
okay.
It provides a mean to declare an abstract variable that can have a specific list of valid values. What you have said it in yeah, in VHDL. Yeah,
Okay,
that is nothing but enumerate. So each value is identified with a user defined name.
okay.
So simply
Okay.
then typed and anonymous enumerations. Anonymous enumeration means what? User enumerated type can be declared as a user defined type. That is also possible. We can declare this enumerated data type itself user defined data type. How means we have to use this keyword type def and enum we have declared type names. This is a data type variable state underscore t. Now in the next line what we are doing, we are declaring two more variables, state and next state, having the data type of this enumerated data type. Then strong typing on enumerated data types. Strong typing in the sense most data types are loosely typed, meaning that any value can have any value of any type can be assigned to any variable. We know that loosely typed or what is tightly coupled, right? So here what's happening, strong typing on enumeration type operation. So enumerated type are strongly typed. Here we can't. Next, casting expressions to enumerated data types. So the result of an expression can be cast to an enumerated data type and then assigned to an enumerated type variable. So we'll see example. You are getting this point, right? We have to cast, then we have to assign it to enumerated data type. Now type def enum wait load ready, same example, state underscore t. So we have declared state and next state of the type of enum. Now what we are doing, next state is equal to state underscore t of, that is the user defined type, and state plus plus 1. So now as we have discussed in the previous slide, state is equal to state plus 1
we are typecasting here
to here. Okay, so it's an legal one. Next, dynamic casting. For dynamic casting, what variable we should use? $cast. So here we have mentioned the name and the expression. So it will cast to this one. So these are all legal one. We'll see some special system tasks. Okay, special methods for working with enumerated list. So you can use like this, that enumerated variable name dot first. Okay, so it will go access that first enumerated name. So it will return the value of the first member in the enumerated list of the specified value. Similarly, we are having dot last. These are all some special system tasks. And like that we are having some more things also. Dot next means next we are inside the bracket we have to mention that one variable name, and previous, and dot num what it will do, it returns a number of elements in the enumerated list of the given variable. Okay, and dot name what it will do, it returns string representations of the name for the values in the given enumerations variables.